Apopka, Central Florida. A scientific team was called in to investigate the declining number of alligators. They found more than they bargained for.
Astonished at what we found. The things that we were seeing were so dramatic. We were actually seeing sex reversal. I mean, things were changing sex. At least 25%, if not 30% of the male alligators on this lake have some kind of abnormal phallus or abnormal penis. Mostly, it appears the abnormality is small size, as much as a half or two-thirds reduced. For this size animal?
It's normally about twice this wide at least, but it doesn't ever has its hook to it like this.
Similar changes to males of other species have been found elsewhere in the United States and in Europe. And now there are signs that human reproduction could be in trouble.
Everything that we're seeing in wildlife has an implication for humans. I believe that we have the potential to have major human reproduction problems.
These are human sperm. They show a high level of abnormality. These have grossly deformed heads, whereas these have no tail. This one is all tail. This sperm has two tails. Here the neck is enlarged with cytoplasm, which should have been shed earlier. And while some are hyperactive, others don't move at all. It was these sorts of abnormalities which scientists from Copenhagen began to study 2 years ago. At the University Hospital, Professor Skakebæk was surprised to find some healthy, normal men who had more than 50% abnormal sperm.
It has been known for a long time that normal men do have abnormal sperm heads, but the percentage of abnormal sperm heads was just very, very high, and all too high to be considered normal in our eyes.
Suspicious that something was going wrong with the process of sperm production, they searched the archives for more data. In the university library, there were studies on sperm counts dating back to the 1930s. They tracked down over 60 studies in the last 50 years, covering a group of almost 15,000 men. These studies revealed a remarkable trend.
It worried us, and we were very surprised that we found a rather dramatic decline in semen quality. We found approximately a 50% drop in numbers of sperm per ejaculate during the period in question, and also the volume of semen had declined during the same period.
Sperm counting techniques have remained much the same throughout this period. The scientists felt that this result couldn't be proven beyond a reasonable doubt. However, they felt a 50% drop in sperm counts over the last 50 years must have occurred.
What we don't know is whether the sperm counts might continue to go downhill. If they do, widespread infertility would be the result.
One of Britain's leading experts in male fertility, Dr. Richard Sharp, was invited to an international conference in Copenhagen, where these results were announced.
Niels was very convinced that this was the real drop. He's not a person who's given to over-exaggeration. He's very cautious. So when he conveyed his concerns to me, I thought it was real. And what this then suggested to us was that, well, something has happened. Something's happened to the process of sperm production, this process that we know very, very little about. And this effect is not a small effect, it's a big effect, and it appears to be a general effect. So something is going on, something big, and we have no idea what is causing it.
But it wasn't just the changes in sperm counts that the scientists were worried about. There was also evidence of an increase in other serious disorders of male reproduction. Colin Thompson has testicular cancer.
Walking into the room, it was like the fear of the unknown. You see this great machine in front of you and you think, my God. I mean, it was pretty frightening at that time.
Okay, now we just check the blocks.
Well, when they first told me I had cancer, it was a shock to me to think that I could lose my life at 30 years of age.
Back in a minute.
The worry was, like, is the cancer going to come back, or is it going to be removed to stay removed?
Within the last 30 years, the incidence of testicular cancer has tripled in the United States and in Britain. It has become the most common cancer in young men. In Colin's case, it was diagnosed early. Now, after surgery to remove a testicle, he stands a good chance of a full recovery.
The sharp increase in testicular cancer is a great concern. In Denmark, we have now 300 or 400% more testicular cancer than we had 50 years ago. And we actually have the highest incidence in the world. And the frightening thing is that we really do not know why.
But what could be causing the increase? Over 20 years ago, when studying tissue samples from an infertile man, Professor Skakebeck came across some peculiar cells which were quite different from the others. These cells, stained brown, have large amounts of DNA in the nucleus.
I immediately knew that these cells were abnormal and they were of some significance, although I did not understand the meaning of it. But it's quite clear to me that they had some excitement of them.
These mysterious samples were filed away, but then a few years later, he came across the same cells in another patient. Because both patients had gone on to develop testicular cancer, Skakebeck realized these cells could be the precursors of the disease.
These abnormal cells looked very different from precursors for sperms. They look much more like very, very primitive cells that you see in embryos.
This was the first real clue that something was going wrong during early human development.
We will return in a moment to Assault on the Male on the Discovery Channel. On the Discovery Channel.
The scientists were worried about another disorder of male reproduction which seemed to be increasing. It was a disorder present at birth, signaling that something was interfering with the normal development of male fetuses.
Hello, Mrs. Ray. I'm Mr. McKinley. Dr. Singh has asked me to have a look at Jordan here because he wasn't able to feel his left testis when he examined him.
Jordan Ray was born with a non-descended testicle.
There's his right testis. That's down in the right place. Yes. You tickling? But the left one, I can't feel. The scrotum's a little bit flat on that side compared to this side. So there's the right one, but the left one is probably just up inside his tummy here. So he is going to need to have an operation to explore the left side.
There are other male reproductive problems which have been occurring more frequently. One example of this occurrence is hypospadias, which is an abnormality in development of the reproductive tract of young boys.
Oh, yeah, it is. Okay. Hypospadia is a congenital abnormality of the penis. It can have a severe form or a very mild form. And in the mild form, it's just a little cleft in the penis. But in its more severe form, it's really so extreme that you can really be in doubt whether this is a boy or a girl. This little boy has had several operations. Fortunately, this has been very successful, but the penis is still somewhat covered underneath subcutaneous fat. So he just now needs a little surgical correction just to reveal the penis underneath the fat tissue. And then I think he'll be fine. He can now stand up and urinate, as a boy should be able to.
Jasper will grow up normally because his condition was mild. In extreme cases, an intersex condition occurs with both male and female characteristics. Figures from other countries suggest the incidence is increasing.
Put all together, then all of this data suggests that, well, there's something that is occurring right about the same time during fetal development, and is there any link between them? Are the changing incidence of testicular non-descent, testicular cancer, and urethral abnormalities, is there any relationship between those? And indeed, can we also drag in the changing sperm counts? And I think it's at this point that when we started asking these questions and saying, can we link them all together, that the next sort of big change in our thinking was about to occur.
Dr. Sharp was then asked to read a paper for publication. It described an extraordinary experiment. By altering hormone activity in newborn rats, the scientists found they could increase sperm counts in adult rats. The scientists realized they had increased the number of what are known as Sertoli cells in the testicles, which are shown here stained brown. The number of Sertoli cells formed in the critical period of development controls sperm output in adult life. The lower the Sertoli cell number, the lower the sperm count. Later that day, Sharp went to a medical library to check everything that was known about Sertoli cells during development. A pattern began to emerge from the literature. Abnormal development of the Sertoli cells preceded various abnormalities in the male reproductive organs.
It soon became very clear to me, in fact, that the Sertoli cell, as in the adult, is really in the driving seat during development.
The Sertoli cell, through a complex pattern of secretions, regulates when the testicles descend, masculinization of the reproductive tract, and the development of the urethra. The Sertoli cell also regulates cell division within the developing testicles. Abnormalities in this process are thought to give rise to testicular cancer.
So suddenly we had this remarkable bringing together of all these facets of the story, so that testicular cancer, testicular non-descent, urethral abnormalities, and via Sertoli cell numbers, sperm counts in adult life were suddenly all brought together as though they were related. And that the reason why we've seen all of these changes in abnormal development of the reproductive tract, falling sperm counts, is because they're all focused through effects on perhaps one cell, the Sertoli cell.
But what could be affecting the Sertoli cells? The one common factor that could disrupt the entire delicate balance of hormone secretions was excessive exposure to the female hormone estrogen during development. By suppressing other hormones, estrogen could reduce multiplication of Sertoli cells and even adjust their number at low levels. Every fetus is exposed to its mother's estrogen in the womb, but the mother's estrogen binds to a protein and doesn't interfere with the developing fetus. But if other chemicals that acted like estrogen crossed the placental barrier, they could then disrupt development.
I was astonished to have taken all these disparate pieces of information which were already there, embedded in the literature, and to come up with a theory that seemed to explain all of these adverse changes that we were seeing. It's a time of real discovery. You feel great elation and a real buzz. Then you have to settle down and start testing it to see if it really is true.
Professor Skakebeck was the first to hear of Sharp's theories. But how could they be tested? The scientists turned their attention to a study of the major medical tragedy involving DES. From the 1950s to the 1980s, up to 6 million babies were exposed to the synthetic estrogen DES, which was given to pregnant women to prevent miscarriage. When Sharp researched the few studies on the male offspring, they showed the predicted increase in the reproductive abnormalities. Unknown to the European scientists, in a lab in North Carolina, research had been underway which linked yet another male reproductive disorder to estrogen exposure: prostate cancer. The number of reported cases of prostate cancer has doubled in the last decade. Dr. John McLaughlin found several important changes in the male offspring if DES was given to their mothers for just 2 critical days during pregnancy.
The thing that really shocked us and surprised us when we looked at the male offspring of these DES-treated pregnancies, they actually had both a male and a female reproductive system existing side by side. They essentially were hermaphrodites. And we figured out that this feminization process of the males occurred early in fetal life when all of us, mice and humans, have both reproductive systems and essentially exist in a bisexual form, and that this process of normal development was blocked by DES, and this led to this feminization.
He was also worried by another unexpected finding.
And it was actually being feminized at the molecular level. And what I mean is that these male mice that were exposed prenatally to DES would actually express female proteins in their reproductive system later in life. And this is something that never happens in a normal mouse.
This is part of the reproductive tract of a normal male. The blue color shows the male has made lactoferrin, a protein which only the female should make. What concerned the doctor even more was the fact that when the mice were a year old, they showed signs of prostate disease.
When we looked at some of these mice as they were getting older and looked at their prostate glands, we were able to see changes in the prostate with a microscope that suggested to us that these prostate glands might be in an early stage of what could eventually be a cancer.
The early stages of prostate cancer are shown by this wedge of abnormal cells. At high magnification, there are cells with an enlarged nucleus, a characteristic of malignancy. The hunt was on to track down sources of estrogen exposure and find out how this had changed in the last 50 years. What was it about modern living that caused an increase in estrogen exposure? Because Sertoli cells continue to develop until puberty, the scientists had to consider everything from pregnancy through childhood. They started with baby's milk.
Well, when we were leaving that night in the car park, I was getting there and suddenly struck me, well, of course, another major source of transfer is into the baby, either through the mother's milk or through the bottle milk. And I sort of got in the car and got out and shouted to Richard, because he was just walking across, "Hey, Richard, what do you think about transferring milk? Because that would get directly into the baby."
That happened on a Friday, and I spent all weekend worrying about it, because I thought that if this was true, then it would create the scare of a lifetime and would have tremendous implications.
After World War II, improvements in dairy farming meant more milk was taken from pregnant cows. Consequently, much higher concentrations of the cow's natural estrogens were introduced into the milk supply. Since cow's milk is used to make most formula foods for babies, was it possible then that babies were being dosed with extra estrogens? Sharp knew that tests on estrogens in milk had been done in another laboratory.
On the Monday morning, I telephoned Professor Brian Heap in Cambridge, and he told me, yes, for certain there were estrogens in cow's milk, but thankfully I think that when they'd measured estrogen levels in formulated baby milk, so what bottled milk is made from, the estrogens had disappeared. So it looked as though it wasn't the switch to bottled milk that was responsible in this case. So I breathed a huge sigh of relief. It would have been nice to have a nice, neat explanation, but at the same time it would have been an extremely worrying explanation to have. There is a sort of an add-on to that, and that is that there's still concern about what happens to estrogen in milk. We don't know if it does get into our bodies if we absorb it, whether that might be influenced by other factors. And we don't know why the estrogen disappears when you make formulated milk and where that estrogen goes. whether it might end up somewhere else. At the moment, we don't know.
We will return in a moment to Assault on the Male on the Discovery Channel. On the Discovery Channel.
At an international conference in Edinburgh, Dr. Richard Sharp aired his estrogen hypothesis for the first time. One of the scientists there alerted him to another possible source of increased estrogen exposure, our diet.
Now, I wasn't aware of this data at all, but studies in Scandinavia had shown that in women you get recycling of excreted steroids from the gut. So they're excreted into the gut, then reabsorbed, and the woman is literally exposed to them for a second time. So you literally get recycling of estrogens.
All the changes that have occurred in our diet over the last 50 years, such as increased consumption of fats and protein, and decreased consumption of grain fiber, have actually increased the recycling of estrogens. These changes alter the environment of the gut so that estrogens, which are being excreted, can be reactivated and reabsorbed.
I was highly delighted to have this idea that diet might be the root cause. But there was one big reservation to it, which I soon realized, and that is, it's untestable. How on earth could you possibly prove it one way or another? There's virtually no way that you can actually relate diet to anything such as sperm counts, or diet of your mother to your sperm counts. So although the dietary changes look to be very important, they are something which we really can't evaluate at the present moment.
While dietary changes must remain a candidate, Sharp was alerted to a whole new source of estrogen exposure. The World Wildlife Fund has been studying the effect of pollutants in the wild, especially in the Great Lakes. It's been known since the 1950s that some chemicals damage wildlife, although it's unclear how they could produce such a wide range of effects. Dr. Theo Colborn thinks that the effects now center on the hormone or endocrine system.
As I began looking again at the literature closely, there were at least 16 top predator species in the Great Lakes that were showing reproductive problems, population decline, fertility problems, immune problems, all developmental problems, offspring, young chicks born with adult plumage. Something went wrong during that embryonic development. You start looking around the country, you'll find populations of sturgeons that are just old sturgeons. They're not replacing themselves, they're not reproducing. We had evidence in fish. Fish in the Great Lakes have thyroid problems. And as a matter of fact, in Lake Erie today, the thyroids are getting so large that they're exploding. Also, the male fish do not reach sexual maturity in the Great Lakes. The fish seem to be hermaphroditic. If you start looking, you can find fish with both male and female gonads in the same species. Below paper and pulp mills, the males are being demasculinized and feminized, and the female fish are being masculinized and defeminized. Well, as I pulled the literature together, there was so much going on. There were so many problems widespread across a whole host of species, fish, mammals, reptiles, and birds, that I had to put it into a huge matrix to make some sense of it. And as I began looking at it, it was very obvious that it was the developmental effects, those effects that prevented the animals from reaching maturity or premature death, that was causing the problems. It was in the offspring. The endocrine system suddenly struck me as being probably one of the underlying physiological systems that was being affected. It was an overwhelming effect. Suddenly I looked at this and said, oh my goodness, what have I found?
Dr. Colborn was so struck by these changes that she organized a conference and invited specialists from all over the world. The Wingspread Conference was a turning point where it became clear that many man-made chemicals permeating the environment can act like the female hormone estrogen and affect health. It's impossible to predict from their shape which chemicals mimic estrogen. Many different molecular structures have turned out to be estrogenic, and the list is growing. including some pesticides and other pollutants like PCBs. We live, in effect, in a sea of estrogens.
The way we think estrogens work, and as well as other molecules that are hormones, is that they interact with a larger molecule called a receptor, and once they interact with that receptor, they can turn on their biological effect. And so you can visualize this molecule of estrogen, estradiol, fitting into a pocket on a receptor, sort of in a lock and key form, and it's that fit that then turns on the biological activity associated with this hormone. These other molecules that work like estrogens probably work the same way. They then would fit similarly in this kind of receptor, fit this same space, and you can more or less see how that might work. What estrogens can do, what these xenobiotic estrogens or foreign estrogens or synthetic estrogens may do, is both work in the receptor and do the same thing that the natural hormone does. They may also block the receptor by fitting in the wrong way and keeping the normal estrogen from going in, and there be a hormone block. They can turn on more receptors, and that can make the estrogen action work more directly or profoundly. They can even change the metabolism of the natural estrogen in such a way that it ends up in a different form in your body, and this can have an influence on the action of estrogen in an indirect way. I think there's so many processes in our physiology that are influenced by hormones. To imagine a sea of estrogens that can affect our development, affect puberty, affect reproduction in a way that is yet even unknown, to me has profound implications for the future not only of humans, but of a variety of different species.
Since such a wide range of pollutants can act like hormones, the conference concluded a large number of man-made chemicals have the potential to disrupt the endocrine system of animals, including humans. And that's what's been happening in Lake Apopka. This is one of the largest lakes in Florida. It's close to the tourist center of Orlando.
You can also shoot to the rear and get out of the wind so if you have a fall.
When local farmers reported a decline in the number of alligators, a group of scientists from the University of Florida was brought in to investigate. They began their research by hunting the nests in the swamps. Every nest, there was something wrong with the eggs. The scientists found traces of a weak estrogenic chemical, DDE, which was contaminating the eggs.
This is a good egg from our control lake, Lake Woodruff. One of the things that you'll note is that you have this beautiful pink, rosy appearance, and that pink appearance means that there's lots of blood flow. This embryo needs that blood flow in those membranes to stay alive. Now, most lakes that we're going to, about 25% of the eggs are bad. 75% look like this. In contrast, if we go back to something like the Lake Apopka egg, what we in fact see is 75% of the eggs look like this. They're translucent, either dead or they're infertile. And in some years, for example, a few years ago, we had as many as 95% of the eggs that were dead.
The males that do survive are demasculinized with high levels of female hormone. 25% have a reduced penis and will never reproduce. Under the microscope, there are many changes in the testicles. These are normal cells, but the animals from Lake Apopka have these bar-shaped cells, which would not be found in a normal testicle and will never produce sperm. Similar changes have been found in the turtles from this lake. Many have become intersex, with reproductive organs more like a female with high levels of female hormones.
What we're finding is that almost as many as 20% of the animals in this population, that is the population of Lake Apopka, have this intersex condition. We are not finding normal males.
The lake was contaminated over 10 years ago by a spill of the pesticide calthene. The major breakdown product of calthene is DDE, an estrogenic compound.
One of the interesting things about Lake Apopka is that it's environmentally clean. Although it was listed in the early 1980s as a severely contaminated lake, today it's believed, as far as chemicals are concerned, toxins, it's perfectly okay. If you go out and take a water sample, the water sample says there isn't a lot there. But one of the scary parts about the estrogenic compounds is that they're stored in fat. And so where they're probably being stored is in all the animals that are out here, not in the water.
These changes are not confined to the United States. In British rivers, there have been disturbing changes to other wildlife. A few years ago, anglers reported hermaphrodite fish, especially near sewage outlets. It was suspected that there was something in the water that was behaving like an estrogen. To test this, scientists working in collaboration with Britain's Department of Agriculture placed male fish in cages in sewage outlets and left them for 3 weeks. Later, blood samples from these males were tested for the presence of the female protein vitellogenin, which would show up if they were exposed to estrogen. The results astonished the scientists. The males were making huge amounts of vitellogenin. The males, in effect, were changing sex. They then tested 28 different sewage plants all over Britain.
We got very positive results at all of the sites that we tested. So the effect is not one localized just to one particular area in the country. It's a nationwide effect and a very, very pronounced effect. I was very surprised at the finding, and the only conclusion must be that there is something in the effluent coming from sewage treatment works that acts as a female hormone on fish. That's the only explanation.
These findings were withheld by the British government for 2 years because they were worried about public anxiety.
In some parts of the country, especially in the summer, the effluent from sewage treatment works is well over half the flow in the whole river. So the river's about not quite neat effluent, but it's certainly 50% effluent. So the substance is present in the rivers as well as in the effluent itself.
A wide variety of weak estrogenic pesticides can be found in river water in parts of England, but not in large enough quantities to account for the changes in the fish. The scientists found another possible cause.
Our initial suspect was a component of the contraceptive pill called ethinyl estradiol. It's a synthetic estrogen hormone. And we suspected that this was extremely potent, and we knew that it's excreted by human females and gets into sewage, or at least we thought it got into sewage. So we ran a series of experiments in the laboratory where we exposed the same type of rainbow trout we've been using in the field to a graded series of concentrations of ethinyl estradiol. And sure enough, we found that ethinyl estradiol is extremely potent and will cause the vitellogenin elevation in male fish at concentrations down to as low as 0.1 nanograms per litre. That's 0.1 parts in a million. So it's an extremely potent compound. The only fly in the ointment is that we've been totally unable to detect any ethinyl estradiol whatsoever in sewage discharges. It doesn't seem to be there. And although I wouldn't totally rule out that ethinyl estradiol is a contributory cause of the effects we've seen, our current thinking is it's rather unlikely to be the causative agent.
We will return in a moment to Assault on the Male on the Discovery Channel.
With contraceptive pills and pesticides not yet proven as causes of the abnormalities in fish, the scientists felt their investigations had come to a dead end. Then a data search found a scientist working in a very different field of breast cancer at Tufts University in Massachusetts. She had stumbled upon a completely new group of estrogenic compounds.
It was an accident. Suddenly, the cell cultures that I was studying, breast cancer cells, started to proliferate or divide like if they were in the presence of estrogens. However, we were absolutely certain that we haven't added estrogens. But it was so clear that they were proliferating and that the only reason for that would be exposure to estrogens. We decided to investigate this problem as if a contamination by estrogens had occurred.
With estrogens being such a critical hormone in the spread of breast cancer cells, they had to track down the mystery contaminant. They tested everything in the lab to find it. The dark blue color shows the cancer cells were still dividing.
After 4 months, we found out that the estrogen was leaching from plastic tubes that we use to store serum. We contacted the manufacturer, and the manufacturer provided us with several batches of his tubes. We could detect it to a point in which they changed the formulation of the plastic. However, when we tried to ascertain the composition of the raw material, we were denied the information because that is a trade secret. So we decided to pursue that in our own because we considered that it was very important to know what this estrogenic substance was.
After spending a few months trying to find out what was leaching from the plastic tubes, they finally tracked down the mystery substance. It was a chemical called nonylphenol.
Nonylphenol is a widely used chemical as an antioxidant in the plastic industry, and it's also used in the formulation of detergents and spermicide foams. Therefore, it's very widespread. And that makes me very concerned because it was never supposed to be an estrogen, and it was always supposed to be safe.
Nonylphenols are widely used in industry and in some household products. The chemical has been in use for over 40 years. In the United States, around 450 million tons were produced in 1993. Nonylphenols are very versatile and have smooth-flowing properties. Because they bind easily to lipids or fats, they are used in paints, industrial detergents, toiletries, agrochemicals, and many other products. They persist in the environment and accumulate easily in animal tissues. The National Rivers Authority of Britain has found nonylphenols present in some rivers in concentrations of 50 micrograms per liter and higher. So could nonylphenols account for the changes in male fish?
We've tested it in fish by adding it to the water, and at 50 micrograms per litre, it's very estrogenic to the fish, and the male fish make very high levels of vitellogenin. That is, the results mimic those which we've observed when we've placed fish in effluent.
If nonylphenols could account for the changes in fish, could they also account for the changes in man?
We've tested them in river water, and they're definitely present. So it's most likely that they're also present in the water taken by the water companies to go to the consumer. And although water is chlorinated and filtered in the treatment works, it's unlikely that the treatment works are doing anything to the water to remove these compounds.
The water utilities say some of the modern filtration methods do screen out chemicals like nonylphenol, but not all river water gets treated this way. In the United States, one recent study did find alkyl phenols present in drinking water in concentrations of 1 microgram per liter.
I started to mull over in my mind as to whether they might perhaps be doing something to the consumers of the water. And the sort of things that came into my mind were they might be affecting fertility in men, and I was aware that male fertility appeared to be reducing. After a few weeks, I rang up Richard Sharp at Edinburgh and put the proposition to him that there might be a connection. It was clear within a few seconds of speaking to him that we were both very interested in what the other one knew, but we knew very different aspects of what might be a similar story.
The two decided to collaborate. In one study, newborn rats were given trace amounts of nonylphenol phenol in their drinking water. The first result showed slightly decreased testicle size. This was an indication of the source of the estrogenic effects. However, far more detailed studies at a range of doses are needed to assess any risk to humans. While working with the British Ministry of Agriculture, Professor Sumter exposed fish in tanks to varying levels of nonylphenol phenol and also found changes. At 30 micrograms per liter, there is a dramatic 1,000-fold increase in vitellogenin and a 1,000,000-fold increase with its chemical cousin, octylphenol. In recent tests, fish placed in reservoirs didn't show any estrogenic effects. But Professor Sumter's team now wants to see tests being done on drinking water. When asked about testing for levels of nonylphenols phenols in drinking water, the British Water Services Association said, "There is no need and no requirement in the UK water quality regulations to look for these substances, nor are sufficiently sensitive techniques available. Hence, routine monitoring has not been carried out." But there has been a more encouraging response from the Paris Commission, which is the international body that sets standards for water quality. It recommended that nonylphenols phenols be phased out by the year 2000 because of their toxicity to aquatic organisms and their persistence in the environment.
Although we may be concentrating at the moment on the nonylphenols phenols, what we can't rule out is that the effects, the adverse effects in man are occurring as a result of a summation of all these estrogenic effects. That it's not just one or the other, but it's all of them together.
There has been increasing pressure to recognize the possible threat of the new estrogens. In Washington, the case for estrogen testing of all chemicals released into the environment and the eventual phasing out of estrogenic pesticides was made before Congress 2 years ago. All the American scientists in this film gave evidence.
It isn't just one product that's causing the problem. It's a host of products. It's the construction material that we're using, the plastics we're using. It is not only the pesticides, and it isn't only the chemicals that we've been releasing in the past that we have banned and restricted, but they're still out there. In essence, what we have to do now is make sure that we revisit every piece of legislation that's coming up for reauthorization to make sure that we include not only cancer as a risk element, but that we include these transgenerational health effects, the effects on the developing endocrine, immune, and nervous system, which are all linked.
We have to look at many different effects, and primarily, we have to test them just like we test drugs. If it's released in the environment, you can eat it, or breathe it, or drink it, then it should be tested, not only whether it causes an effect in you as an adult, but whether it affects a developing child as well.
We have no way of knowing at the moment whether our children, how they're going to be affected when they grow up. And we've got to wait 20 years for that, for sperm counts, etc. So it's something that we need to be concerned about now, because it could be affecting people a long time in the future. And they're not going to thank us if we sit back and do nothing now.
Imagine if, for the last 50 years, we had sprayed the whole Earth with a nerve gas. Would you be upset? Would I be upset? Yes, I think people would be screaming in the streets. Well, we've done that. We've released endocrine disruptors throughout the world that are having fundamental effects on the immune system, on the reproductive system. We have good data that shows that wildlife and humans are being affected. Should we be upset? Yes, I think we should be fundamentally upset. I think we should be screaming in the streets.
It is still unknown which chemical or combination of chemicals are causing estrogenic effects, or how we're being exposed to estrogens, whether through water, diet, or some other means of exposure. But what is known is that the changes to human reproduction are real, and the hunt is still on to pinpoint the key culprit from within this sea of estrogens.
Tomorrow at midnight Eastern and Pacific, investigate the Peacock's war on Discovery Showcase. Then explore the famed geysers of Yellowstone National Park on America Coast to Coast.